Hey, welcome back. We're going to continue with 6.1 today, Properties of Exponents, Part 2. In Part 1, we learned the rule of zero and the rule of negative exponents. So if you need to go back and review that, you can head over to YouTube and find that video there. It's public. 6.1 Part 2, though, we're going to learn 3 new rules today: the addition rule, subtraction rule, multiplication rule. And we're going to learn how to apply those. So hopefully you're ready for some learning, and here we go. So the first new rule we're going to learn is called the product of powers property, and you'll often hear this referred to as the addition rule for exponents. And so if we're doing a product of powers property, what that's saying in words is to multiply powers with the same base, we can add the exponents. And what that kind of looks like in symbols is if I have x to the a times x to the b. So again, one power would be x to the a, a second power would be x to the b, and I'm multiplying those two powers together. That's why it's called product, meaning product is a multiply of two powers property. When I'm multiplying two powers together, the rule says if they have the same base, I can add the exponents. So I keep the same base, which is x, and I'm going to add a plus b. Right? That's kind of our rule, addition rule or product of powers property. And what that might look like with numbers is, let's call this example 1a, is if I have something like 4 to the power of 6 times 4 to the power of 3, I notice that they have the same base. If they don't have the same base, there's nothing I can really do here. And the rule says I can do 4, keep the same base, to the power of 6 plus 3, which is 4 to the power of 9. And the reason why I can do that is 4 to the power of 6 is just 4 times 4 times 4 times 4 times 4 times 4. There's 6 of them, right? So this 4 to the power of 6 is 6 4s multiplied together. That's what it means to be an exponent 4 to the 6. And 4 to the power of 3, that's going to be 3 4s multiplied together. And I'm multiplying those two powers together, right? So really that's a string of 9 4s multiplied together. And an easier way of writing 9 4s multiplied together is 4 to the power of 9. Alright, you go ahead and try one here. 3 to the second power times 3 to the sixth power. Go ahead and use our rule for the product of powers property and enter your answer when you're ready. So on this one, they have the same base, 3. I'm going to add the exponents 2 plus 6. I'll end up with 3 to the power of 8. And again, if I wrote out the string, it'd be 2 3s here, and then 6 more 3s here. Again, all multiplied together, which is the same thing as 8 3s all multiplied together, 3 to the power of 8. Alright, that's our first rule, the product of powers rule. We got 2 more to go. Alright, our second rule is called the quotient of powers property. Oftentimes you'll hear that referred to as the subtraction rule for exponents. And what the quotient of powers property says is it says in words to divide powers with the same base. So to divide powers with the same base we subtract the exponents. Alright, so that's kind of our rule. To divide powers with the same base, we're going to subtract the exponents. If we think about what that kind of looks like in symbols, what it's going to look like is if I have x to the power of a, and I'm dividing it by x to the power of b, and that has the same base, right? Again, that base number is the big number, x there. They have the same base x, so I can keep that same base and subtract the exponents a minus b. So that's kind of what this one's going to look like in symbols. Now that we know what it looks like in symbols, we can try a couple examples of it. So the first example we're going to look at is, I'm going to call it example 2a, and we have 4 to the power of 8 divided by 4 to the power of 3. And if you notice, that base is the same. So like in the algebra like notation here, x is our base. And you can see in our problem 4 is going to be our base here. And then the number 8 is corresponding to A, and the number 3 is corresponding to B. So my rule says I can keep the same base, 4, and then subtract A minus 3 in the A minus B, so 8 minus 3 in the exponent. And 8 minus 3, of course, is 5, so I'm left with 4 to the power of 5. Now, the reason why this can work is if I have 8 4s in the top multiplied together, 6, 7, and 8, and I'm dividing by 3 4s multiplied together in the bottom, I can do some simplifying by reducing a fraction by canceling 1 4 from top and bottom. So 4 over 4 makes 1, 4 over 4 makes 1, 4 over 4 makes 1, and what I'm left with is 5 4s multiplied together, or 4 to the power of 5 is an easier way of writing that, right? And a quicker way to get to that answer is to use our subtraction rule, or what is more formally called the quotient of powers property, right? So 4 to the 8 divided by 4 to the 3, we can just do the subtraction rule, 4 to the 8 minus 3, which is 4 to the power of 5. Alright, I got one for you to try here. Try 7 to the power of 7 divided by 7 to the power of 2. Go ahead and try that one out and enter your answer when you are ready. Alright, so for this one I'm going to keep the same base. Again, my x now for the base is 7. I'm going to subtract my exponent, 7 minus 2. Of course, 7 minus 2 makes 5, so I'm left with 7 to the power of 5 on this one. We've kind of gone through our addition rule and our subtraction rule. We have one rule left, which is our multiplication rule. Alright, so our third rule is the power of a power property. This is our final rule for today. What the power of a power property says is to find a power of a power. So that's like raising a power to a second exponent. So when finding a power of a power, multiply the exponents. And what that kind of looks like in symbols, if I have x to the a raised to the power of b, so I have one power here, and I'm kind of forming a second power out of it. So I have one power, but then if I use that whole green thing as the base, I have a second power, right? So I'm creating a power of a power. When I have a situation like this, what I can do is I can multiply the exponent. So I keep the base x to the power of a times b. And so this is our third rule. We have our addition rule. That's when you're multiplying two different powers together. We have our subtraction rule when you're dividing two powers. And then when we take a power of a power, we're going to multiply the exponents. So an example of this one, I'm going to call it example 3a, would be if I took 3 to the 6th power to the power of 2. Now, where a lot of people kind of go wrong on this one is they're going to end up saying the answer is 3 to the power of 8, and they're going to add that 6 and 2. If we look at our rule here, it's just 3 is the base x, and then a times b. So a is 6 and b is 2. So we're going to end up doing 6 times 2, which is 12, not 8, right? And the reason why I end up multiplying those numbers is the following. When we're taking something and squaring it, so anything squared, so if I have x squared, that means x times x, right? So in this case, my x is 3 to the 6. So I have 3 to the 6 times itself. And that actually becomes an addition rule where I could do 6 plus 6 for 12, so 3 to the 12. And the reason why that works is 3 to the 6 is 3 times itself, 6 times, then 3 to the 6 again, so 6 more 3's, right? And then in total we'd have 12 3's all multiplied together for 3 to the 12, right? And I think it's helpful to just go back to that string, like of numbers written out, and kind of prove it to yourself if you forget the rule. So in this case, we're going to multiply. So 3 to the 6 times 2 would make 3 to the power of 12. And kind of our proof of that is over here on the side. Part B, you're going to try it. So for part B, we're going to do 2 to the power of 5 to the power of 3. Not a very good 3. So 2 to the power of 5 to the power of 3. Again, we're using our power of a power or multiplication rule here. Go ahead and try that one and enter your answer when you're ready. So again, we're multiplying here, so we're going to keep that same base. 2 is my x here, or my base. And then my a is 5 and my b is 3, so I'm going to multiply 5 times 3 in the exponent, and I'm left with 2 to the power of 15. So those are 3 rules. We're going to have you try 2 problems just to make sure you can differentiate between those rules, and then you should be ready to go on this one. Alright, let's take a look at example 4. The tougher part about this section actually is not actually doing any of the rules. All of the rules were pretty straightforward. It's just remembering what to do. So let's take a look at y to the 8 divided by y to the third. And on this one we have to figure out, do I add the exponents, do I subtract the exponents, do I multiply the exponents? So figure out which one you would do here, calculate it out, and enter your answer when you're ready. Yes, this is a quotient of powers. Hopefully you realize that. And so quotient of powers, I'm going to subtract, right? So y to the power of 8 minus 3. Of course, 8 minus 3 is 5, so I'm left with y to the power of 5. Again, it's important just so you remember, do I add, do I subtract, do I multiply? Which rule am I doing? One more for you here. Example 5. We're going to take a look at x to the power of 9 multiplied by x to the power of negative 9. Again, do I add, do I subtract, do I multiply? What type of rule is this? Go ahead and figure that out, calculate it, and enter your answer when you're ready. Yeah, so I'm going to add here, this is a product of powers, so I'm going to end up doing x to the 9 plus negative 9. This one's a little bit tricky because it turns out 9 plus negative 9 is 0, so I'm left with x to the power of 0. And our rule of 0 from yesterday, we know anything to the power of 0 is just 1. So thanks for staying with me there. We kind of got to the end. Good luck with your big ideas practice, and I'll see you next week.